Assalamualaikum, and we are honoured to present our project for the assignment under the Faculty of Engineering Technology at University Technical Malaysia Melaka. Our presentation today focuses on the non-destructive testing entity of a metal chair mounting plate, a critical component in ensuring structural safety and reliability. Okay, before we begin, allow me to introduce our teammate. I'm Muhammad Hairi bin Mazlan, and joining me Muhammad Azri Naimi, Muhammad Alif Akmal, Nur Atirah binti Zakaria, and Umi Nabilah binti Muhammad Nur.
Hi everyone, my name is Nur Atirah binti Zakaria, and today I would like to share about prediction of possible flaw or defect in our assignment. So, for this assignment, our group chose mounting plate of a metal chair as the material to be tested. This component is typically located where the seat is connected to the leg or base of the chair. It plays a crucial role in supporting the load and in ensuring structural stability. When analyzing potential defect in this part, we focus on two main issues, which is first, crack. These are likely to occur around bone hole, weld joint, or at the corner where the stress tend to concentrate. Cracks often develop due to fatigue, which result from repeated loading and unloading during everyday use. Sharp transition or weak welding point can accelerate crack formation. So second, the porosity. This defect may appear internally, especially if the plate was welded or cast. Porosity is commonly found in weld or in a thicker section where gas can become trapped. It's often caused by poor welding practice, such as improper shelving gas, contamination, or incorrect heat setting. In summary, the likely defect location in this mounting plate included around bone hole, weld joint, and high stress area. The main causes are fatigue and inadequate welding technique. So by selecting this component, we aim to evaluate its structural integrity and identify any potential manufacturing or fatigue-related defects during our testing. For the next part, we're choosing the selection of suitable entity method. For this assignment, our group chose dye penetrant testing. So, in our testing method, we select dye penetrant testing or PT as the most appropriate technique for inspecting the mounting plate of the metal chair. This method was chosen because the defects I will be expecting, such as crack and surface porosity, are open to the surface. PT is specifically designed to detect fine surface cracking discontinuities, including hairline crack and surface porosity, which are common around bone hole and weld joint. PT is highly suitable for metallic component like the mounting plate and is widely used in welding inspection and machine part quality control. So the main advantages of PT are: it offers high sensitivity to small surface defect, it is cost-effective and widely accessible, the procedure is simple and requires minimal training, it works well on large surface area and complex geometry. Overall, due to the nature of the defect and the material, we think PT is very reliable and efficient choice for our inspecting problem.
Okay, before conducting any non-destructive testing or entity, it's essential to carefully consider several key factors to ensure the method chosen is both effective and appropriate for the component being tested. Let's begin with the material. The mounting plate of the metal chair is made of mild steel or iron, which is compatible with dye penetrant testing. However, for dye penetrant testing to be effective, the surface must be clean, non-porous, and free of heavy rust or coating. Next, we look at the defect type. PT is ideal for detecting surface breaking defects such as crack and open porosity. Since the suspected flaws are visible or accessible on the surface, PT is highly suitable. Accessibility is another important factor. The mounting plate has a flat and exposed surface, which allows easy application of the penetrant developers and cleaner. This means we can inspect all critical areas without needing to dismantle the chair structure. Now, let's talk about cost. PT is a low-cost method that doesn't require advanced machinery. It is budget-friendly and suitable for student level or in-house inspection, especially when multiple tests are needed. Equipment availability is also crucial. PT kits, including penetrant, developer, and cleaner, are widely available in most entity labs. They are portable and easy to use in both workshop and on-site environment. Finally, we consider safety and simplicity. PT is a safe method when proper products are used, involving non-toxic chemicals and no radiation or electrical hazard. It's simple enough to be conducted by trained students under supervision.
Okay, my name is Muhammad Alif Akmal. I will explain. For my part is execution and explanation of NDT procedure method used for my project. We use dye penetration testing, which means PT. For the equipment, number one, we use penetration, cleaner, developer, clean free clothes, and glove. For the surface cleaning, step one, we clean the mounting plate using cleaner to remove DT, oil, or rust. Okay, for the application of penetrant, we apply red dye penetration spray evenly on suspect crack and porosity area, and then leave it to dwell for 10 minutes for penetration into surface defect. Next, access penetrant removal, wipe off surface penetrant with a clean clothes and apply cleaner to ensure only penetrants inside crack remains. Number 5, we apply the developer, apply white developer to draw out penetration, track in crack or pores. Lastly, we observe for any red indication against the white developer background, which means red line is cracked, and red dot, which means porosity.
Assalamualaikum, my name is Muhammad Azri Naimi bin Rizwan. For this slide shows the evolution of our test result using dye penetrant inspection. We can clearly observe red line indication around the bolt holes. This line indicates the present surface crack likely caused by stress concentration. In addition, we found several red dot clusters near the weld area, which is a sign of porosity within a material. The defects were mainly located around stress concentrate areas such as bore hole with a diameter of 10 mm and thin edge less than 0.2 mm. These locations are typically prone to crack formation due to high localized stress. Porosity was also detected in the weld head affected zone, which could compromise the strength and integrity of the weld. These defects are surface breaking and significant, therefore, further evaluation or repair is strongly recommended before using the component, especially in safety critical application. In this slide, we analyze the root cause behind the defect found during inspection. Starting with the cracks, the way likely caused by stress concentration, mainly due to frequent holding and the over tightening of bolts. This action put repeat strain on localized area, especially around bolt holes. Over time, this lead to fatigue and small cracks start to form and propagate into large micro cracks, weakening the structure. Next, we look Next, we look at the porosity found in the weld area. This most likely caused by a pure welding technique, which allow gas entrapment during solidification of the weld. Other possible factors include inadequate pre-cleaning of the base material and improper shielding, both of which can introduce contaminant or allow air to enter the weld hole. Identify this root cause helps ensure that corrective action can be taken, not just to fix the current part, but also to improve the welding and assembly overall.
Okay, hi and Assalamualaikum. My name is Umi Nabila binti Muhammad Noor. I will continue with the risk assessment of failure. Let's begin with the risk assessment of failure for our component. First, we have crack risk. Crack may lead to structural failure if the component continues to bear load without any repair. These cracks pose a high danger as they can cause sudden fracture, especially under dynamic or heavy loads. Okay, next, porosity risk. Porosity within welds can compromise weld strength. Over time, this can result in crack initiation during long-term use, reducing reliability. Okay, lastly, the severity level. The combined impact of cracks and porosity place this failure at a medium to high risk if less unaddressed. This is particularly critical in items like chairs used frequently or by heavier individuals. Okay, now let's go over the recommendation for improvement based on the risk identified. Okay, first, we can recommend for design improvement. It's advised to use rounded corners rather than sharp transitions. This helps minimize stress concentration and improve overall durability. Okay, second, welding improvement. We should enhance welding process control, including the use of proper shielding gas and cleaning surface before welding. Additionally, pre-weld and post-weld inspection are crucial to ensure quality and detect yearly defects. Last but not least, preventive maintenance. Regular NDT inspection will allow us to identify and resolve defect yearly. Also, we must be cautious during assembly. Avoiding over-tightening bolt can help prevent structural stress and failures. Okay, that's all from our group. Thank you.